Meet Willow, Google's quantum chip that just cracked reality as we know it. But why is it causing concern for Bitcoin? So today we'll chat about why this one breakthrough will change our world as we know it, how quantum will affect the future of Bitcoin security, but first, let's see how this shattered benchmark caused instant panic.
God, okay, it's happening.
It all starts with the random circuit sampling, or RCS benchmark. So who are the contenders for RCS? Well, in the left corner, we have Capitan, the world's largest supercomputer with over 1 million CPUs and 10 million GPUs. And in the right corner, we have Willow, Google's new quantum chip that can fit in the palm of your hand. And the results? Well, Capitan managed to crush this out in 10 septillion years, or this many years, while Willow held strong and solved it in 5 minutes. Let's just let that sink in for a moment. Naturally, this sounded the alarms for all crypto bros. Bitcoin's encryption is dead. Quantum apocalypse incoming. Sell everything. If this thing can solve complex problems in just 5 minutes, while the most powerful supercomputer in the world took longer than the age of our universe, what's stopping any wallet from being brute forced within seconds? Well, here's what those battle cries aren't telling you. Bitcoin isn't dying. It's not even close. But in reality, does this fancy benchmark mean anything for us in our daily lives? Isn't quantum just another computer type? Well, first, let's understand what Google actually built. Let's keep it simple. Your computer, the one you're using right now, works with bits. Bits are like a light switch. It's either on, 1, or off, 0. Now, quantum computers, on the other hand, use something called qubits, which is like a bit, but there's a third position. This is the same thing as our light switch example, but this light switch has a dimming feature, which makes a qubit super powerful because they can hold on to a lot more information. So what does Willow bring to the table? Well, we have a 105 qubit processor, revolutionary error correction, unprecedented stability, and solved one very specific problem. Now, out of this list, there is one thing that is huge for quantum computing. Which one do you think it is? Well, it's error correction. Now, why would error correction have this massive impact on our world? Well, quantum computers has always had a villain to face: errors. Errors are the biggest headache because quantum bits are just like me at Best Buy. They're super prone to distractions. Now, typically when you add more qubits, you add more chaos, and suddenly your neat little calculations are just a jumbled mess of spaghetti. But Willow has cracked a quantum conundrum by massively reducing errors every time they scale up, which now means quantum computers can actually become a thing in our daily lives and not just something in a lab. This will change our perception of what is possible in the world. We're talking about potential breakthroughs in medicine, energy, and even artificial intelligence. Impressive? Absolutely. Bitcoin killer? Not even close. This poses the question, are quantum computers a threat to Bitcoin security? Let's put this into perspective. It's estimated that quantum computers with about 13 million plus qubits could theoretically break ECDSA encryption, reverse engineer private keys, access any wallet, and move funds without permission. The keyword, theoretically. Well, let's look at the cold hard facts then. Willow has about 105 qubits. 13 million plus qubits are needed to break Bitcoin. That's shy about 23,800 times improvement. Now, even with Moore's law, we're decades away. But here's the kicker. The Bitcoin community isn't just waiting around to find out. In fact, the great Satoshi Nakamoto went full Miss Cleo and predicted this thing 13 years ago. Here's a 2010 forum post Bitcoin creator addressed quantum computing. SHA-256 is very strong. It can last for decades unless there's a major breakthrough and attack. Satoshi even outlined a complete contingency plan for transitioning to a new cryptography if needed. Of course, since then, Bitcoin has built a proven track record for evolving past threats. 2017, SegWit solved scaling plus killed transaction malleability. 2018, the Lightning Network enabled instant free transaction. 2021, Taproot brought enhanced privacy plus smart contracts. Each upgrade made BTC stronger, and the quantum resistant plans? Well, they're already in motion. These include upgrades like Sphinx plus signature implementation, lattice-based cryptography integration, hash-based signature schemes, zero-knowledge proof layers, multi-layered validation system, quantum-resistant address formats, time-lock security features, and emergency migration protocols. Now, these aren't just concept. They're actually being tested on Bitcoin's testnet right now. So while the critics are panicking about theoretical threats, Bitcoin devs are building solutions for problems that don't even exist yet. By the time quantum computers have enough power to threaten Bitcoin, the network will already have evolved way beyond their reach. It's not a question if Bitcoin will become quantum resistant, but when. So now that you can fall asleep knowing quantum won't break into your piggy bank at any time soon, and you want to learn more about another emerging tech happening right now, check out this video on AI agents and get ahead of 96.5% of people in the world. I'll see you over there.